I thought this was it, but I did add one question. Now you're going to see this. In fact, your notes will look slightly different. Your G is something somewhere. Your G is down here. No, your G is up there, but the question that was here, I've now pushed to up there. So you would have already noticed that things are kind of odd. And there's this question here that hasn't been answered. In fact, there's a question F or what was here originally, I think I deleted. I can't remember what I deleted, to be honest. But I did add this question, and this is the end all and be all of this section, which is linear equations. So the idea is we create an equation, and then we can use the equation to predict in the future. Very much like how we did a line of best fit, and we could then use the graph and try to predict. We could interpolate or extrapolate. Here we're going to do the exact same thing, but with an equation. So it says here, the plumber works 7 hours. How much money would he make? And so if you could see here, like I created this line, and you could go up 7 hours and go up to here and take a look. And you could say, well, 7 hours goes up here, and then over here looks like around 450. But how could we do that with an equation? So equation process. Then we don't even have to do any graphing, which is kind of nice. If we can have the initial value and the slope, we can just put it into this equation. So this is the equation of y equals mx plus b. But we know the m was 50, and the b was 100. And it said the plumber worked 7 hours. And so that is our x. We labeled x as hours. So if you look up here, the hours worked, you can see we labeled that as x. And then the how much it would cost, how much the plumber would get paid, is going to be our y. So it says that our x is in hours, so we just need to take this equation, and instead of x, we can just write 70. And then, or sorry, 7, not 70, 7, and then we can add 100. So then you get 50 times 7, which is 350, plus 100, and it equals 450, which is exactly the same thing we got if we had predicted. Now, you might get a different answer depending on your line of best fit. And so if your line of best fit wasn't exactly accurate, you might not get 450. You would have got, you bring 7 up to your line, and you pull it over, you might get 470 or 430. But if you use the equation, you will always get the exact amount. So that's why the equations are really powerful. Now, on the worksheet, which is the next page, I'm going to jump ahead a little bit here. And it asks, Miranda works 5.5 hours. How much money would she earn? So that is our x. And so when it comes to the equation, you just plug 5.5 in to the equation, and you can look at the answer key for that. But what I want to do is look at this one where it says, what if Miranda, and Miranda is kind of like the plumber or whatever. I don't know what job it is in this one. I haven't looked. I forgot now. But well, now I'm actually curious. What kind of job does she have? Calculate. Oh, babysits. Okay, so for this question, the compared to the other one said, if they worked 7 hours, how much money would they make? And now this one's saying, well, let's say that they made 160. How many hours did they work? So it's asking the exact opposite question. We could have said, in 7 hours, how much money would she make? But here we're saying she's made 106. So when you have the equation, and I don't have it here, what is it? 8x plus 10, which again, you have no idea. Where does 8x plus 10 come from? Well, you're going to have to do the worksheet. But the last time we put 7 into here. But now we don't know how many hours. We want to know how many hours. And so now we're going to plug 106. Miranda and babysitting made $106. So you have 106 goes in for the y. And so those are the two questions I can ask. I can give you the y and ask you to find the x, or I can give you the x and ask you to find the y. This one requires some algebra at this point, which is why this comes after the algebra unit. So you can minus 10 from both sides and then divide by 8. And I'm not going to do that. I'm going to let you try that, though the answer key is on there. But just taking a look at these two questions here for Miranda, There's the question there. I gave you the X. I said, X is 5.5. That's how many hours she worked. What is the Y? And then here I give you the Y. And I say, well, how many hours has she worked? So they're asking the complete opposite. One's asking for the X, one's asking for the Y. One gives you the X, the other one gives you the Y. And so you're going to have to try these on your own and see what you get. So that's why I added this question here. We could, if I wanted to, I could say, well, to ask what would the opposite question look like? Well, if I said, well, the plumber made $700. Say I said the plumber made $700. How many hours did they work? So if the plumber made 700, y equals 50x plus 100. And now I tell you what the total is. The total is 700. And so I have to plug that in. And then I'm asking you to find the hours or find the x. So from there you can minus 100. So that gets you 600 on that side and 50x over there, and you can divide by 50 and divide by 50. So your x equals 60 divided by 50, which is going to be like 12 or something. So I think it's 12. So then you can say, well, the plumber worked 12 hours to make $700. So you need to understand the difference. Here I said, hey, the plumber worked 7 hours. How much money? Here I said, here's the money. How many hours? So they're opposites. So you just need to know that, and that's the biggest part. So that's the question. Those are the questions I'm going to ask you on your test, which is why I gave you an example down below from Miranda and babysitting for you to practice.